Hello everyone. Today we're gonna show how to calculate the Formant frequencies for a N-tube model that represents the vocal tract in speech, and we're gonna also draw a signal flow diagram of lossless N-tubes model representing this vocal tract. So we'll do both, and one of them. The first question of how to calculate formants, I'll give that as a question from an actual midterm or a final exam that you might have as a course. So the first question states, find the formant resonance frequencies for a two-tube lossless model of the vocal tract, where area 1 equals 6 centimeters square with a length L1 equals 8.5 centimeters, area 2 equals 3 centimeters square, L2 equals 8.5 centimeters. So we have the first cavity is bigger than the second cavity. So let's draw this first. Okay. So this is area 1, 6 centimeters square, area 2, which equals 3 centimeters square, L1 equals 8.5, and L2 equals 8.5 as well. Okay, so we want to find the first three formants. Okay, the first thing we need to calculate is the cotan asymptotes and the tan asymptotes. As I put earlier, the formula that we're going to use to get these formants is going to be a cotan beta L1 equals A1 over A2 tan beta L2, where beta equals 2 pi f of I over c, and then from there we get f of I. Now to get the asymptotes for cotan asymptotes, that's going to equal n pi over L1, and for the tan, that's going to equal 2n plus 1 pi over 2 over L2. So okay, before we calculate these, let's draw a plot here to show exactly what we're going to do. Okay, so n pi L1, let's start with 0 here. It's not going to be, of course, at 0, but if you put 0, let's say it's a little more than 0, the asymptote, it's going to be right around here. So I'm gonna say about 0, and then the next one at pi, if you substitute n for 1, that's pi over 0.085, that's around 37, and the next one 2 pi over L, that's gonna be around 74, and the next one 3 pi over L1, that's gonna be around 111. I think that should be sufficient. Okay, now for the tan, if we substitute, start with 0, so it's going to be pi over 2L. So pi over 2 times 0.085, and we have 18.48. Well, let's just say 18.5. Next, we have, let's see here, if we substitute 1, 2 times 1, 2 plus 1 is 3 pi over, okay, so that's going to be around 55.5. And then let's see here, if we substitute, sorry, before it was 3, now n equals 2, so 2 times 2 is 4, plus 1 is 5, so that's going to be 5 pi over 2L2, which is around 92.4. And I guess we can do one more. 3 times 2 is 6, plus 1 is 7, and that's going to be around 129.4. Okay, let's see here. Now we need to draw these. Let's see, 0, 7. So we need to draw these. Okay, 18.5. See, 0, 18.5. Let's say this is around 37, and then 55.5, 74, 92. And then 111. Okay, so 18.5, 37, 74. Nope, sorry, 37. This would be around 55. This is 74. This is 92, and this is 111, etc. So these are all asymptotes. What I'm looking here is for beta, and beta is going to be the intersection where the cotan and tan intersect. But I just wanted to plot this so you can get an idea of what is it exactly that we're doing. Okay, so let's start with the cotans. So the cotan is going to go all the way from here to here. It's going to cross kind of like that. Okay. And then the next one, same thing. And the next one, just like that. So those are the cotans, and the tan will go, that's one, and the second one, let's see here, yeah, the second one will come just like that, and this one, let's see here, 74, okay, yes, so this one will come from here, just like that. Now the intersecting points are the beta 1, beta 2, and beta 3, and this is what I want to get f of 1, f2, and f3. I need these three beta values. So now, how to get these three beta values, B1, B2, B3. I'm gonna show you on the calculator here. Okay, let's start with beta 1. We're gonna use this formula right here. So we're gonna go cotan is of course 1 over 10, 1 over 10. Let's see, alpha x 0.085 is L1, and that's gonna equal alpha solve equals, this is what you want to press, and a1 over a2, you have 6 over 3. That's gonna equal 2, but I'll write it anyways as 6 over 3. I don't need to convert it, of course, to meters because centimeter square cancels each other. And 10 beta L2, so L2 is how much? Convert to meters, 0.085 alpha x for beta, and close the parenthesis, and now we're gonna go shift solve for x. This is just the number that was stored from before. So solve for x, how much should I put for x right now to get a value for beta 1? The value I want to put for x is, see this, remember here, this 18.5, which was the one of the values for tan. The first value here we on the line was 18.5. So I can put for x any value greater than 0 and less than 18.5. Choose anything. I don't know, put like a 10 and then press the equal sign and wait for a few seconds. It'll come out with a value. There we go. So 7.24. So beta 1 right here, beta 1 equals 7.24. Now for beta 2. Now I'll just go back here, and all I gotta change, let's see, is shift solve for x. Now how much should I put for x here? It has to be greater than 37 and less than 55.5. okay, so I don't know, greater than 37, let's make it 45, and equals. Wait a couple of seconds. I got 44.2. So beta 2 is let's see here, equals 44.2. okay, I'll go back, shift solve, and for beta 3 I need something between greater than 74 and less than 92.4. so I'll just put like something like 85. Whatever value you put, by the way, it's gonna get the same answer as long as you're in this domain. Wait a few seconds, and B3 is 81.16. okay, so now I have my B1, B2, and B3. From here it's very easy to get F1, F2, and F3 because beta equals 2 pi f of I over c. So beta 1, let's see here, equals 2 pi f1 over c. C equals as the speed of sound, 340 meters per second. And if you calculate that, calculate that, f1 should equal around 390 hertz. And for beta 2, same thing. Of course, here you have to substitute 7.24, and beta 2 equals 44.2, which equals 2 pi f2 over 340, and f2 would equals, the second formant is gonna equal around 1610. Of course, I'm rounding off here to the nearest 10. And same thing if we calculate for f beta 3, which equals 81.16. f3 is gonna equal somewhere in the neighborhood of 23, about 2390 hertz. So there you go. I have my first 3 formants. This is everything you need to know. If you get a question like that on a midterm or a final, this is for a 2-tube model. By the way, this 2-tube model, if asked what phoneme might it represent? Well, this represents the I sound. Okay, and same thing you might need to calculate for the or something else. Now for the same question, let's draw a network flow diagram very quickly. Okay, so let's draw here very quick, and let's see here. Alright, now this is a 2-tube model. So if you have 2 tubes, so n equals 2, let's see here, the delay elements, you can have n delays also, which are going to equal 2, and the junctions equals n minus 1, which equals 1 junction. Okay, so we're going to start here at the 2 tubes. There's 1, there's 2, and there's a junction area. Let's see, delays and delays, and it says UT at the glottis, and this is UT at the lips. This is tau 1 and tau 2, tau 2. Okay, and this is gonna be 1 plus R1, 1 minus R1, and let's see, coming here, minus R1 plus R1, or glottis minus R lips. Okay, by the way, the delays, T of or tau of I equals Li over C. So for this tube, since, well, they're both the same length anyways, but for this tube, alright, let's see, it's going to equal, for tau 1, tau 1 will equal, what's the length here? 0.085 in meters over 340, and that's gonna equal how much? Let's see here. 0.085 over 340, and that's gonna equal 25 milliseconds. Okay, what is 25 milliseconds? That's the delay. That's the time it will take the sound to go from one side of the tube to the other side of the tube. And for tau 2, it's gonna, because the length here is the same, so it's gonna equal the same thing, which equals 25 milliseconds. Okay, now we need to calculate R1, and we need to calculate R1, so we can calculate 1 plus R1, 1 minus R1. So R1 is going to equal A2 minus A1 over A2 plus A1, and this is going to equal, A2 is how much? 3 minus 6 over 3 plus 6. So minus 3, no, sorry, 3 plus 6 minus 3 over 9 equals minus 1/3. And 1 plus R1, let's see, equals 2/3. 1 minus R1, it's 1 and 1/3. 4/3. Okay. So now we have pretty much all the substitutions that we need, and this is just a general quick idea of the network flow diagram, because you might get asked to draw it. And if you have 3 tubes, then you're gonna have 2 junctions. You're gonna have 3 delay elements, and you just need to calculate everything. That's it for now. Thank you very much. If you have any questions regarding things like this related to speech, please let me know. I appreciate it. Thank you. I hope this was to your benefit. Please give us a like and subscribe to encourage us to put more videos that can help students with various topics. Thank you.